Have you ever tried digging a deep hole at the beach? You get down to the wet sand, scoop out a big handful, and immediately the sides just cave right back in. It turns out the engineers building mega projects like the new Mumbai-Ahmedabad high-speed rail face that exact same frustrating problem, just on a massive scale. To solve it, we first drill a massive hole. That's the boring part. Then, we build the foundation right there in the ground, or in situ, creating a deep underground support called a pile. You can't just rest a heavy concrete railway on top of soft, squishy topsoil. You have to reach down into the earth until you hit hard, supportive rock. To build massive, heavy structures high in the air, we first have to figure out how to dig these deep roots without the surrounding earth crushing the hole shut. Construction crews start by bringing in massive rotary drilling rigs. These towering machines are capable of gouging out holes up to 4 meters wide. And they dig deep. A single shaft can drop over 100 meters straight down, putting the bottom well below the natural water table. But remember the beach sand? The deeper the drill goes, the more the heavy soil and water push inward, wanting to collapse the walls. To hold the walls up, engineers fill the hole with a specialized heavy fluid called bentonite slurry while drilling. Because it's denser than normal water, it creates an outward pressure, pushing against the walls and holding the dirt perfectly in place. So the walls are secure. The only problem is that the giant hole meant for our concrete foundation is completely full of thick, soupy mud. Next, a massive woven cylinder of steel rebar is lowered into the mud. This metal skeleton gives our concrete pillar flexibility to handle passing trains. Now we need to add the concrete. But if we drop it in from the top, it will splash and mix with the bentonite mud, ruining the strength of the foundation. A long steel tube called a trolley type slides through the mud, reaching the very floor of the shaft. Heavy, wet concrete is pumped straight down this tube, pooling at the lowest point. Because the concrete is heavier, it acts like a giant liquid plunger. As the concrete pool grows, it pushes the lighter mud up toward the surface. The pumping continues until the entire shaft is full, forcing the stabilization mud completely out the top. By pouring from the bottom up, engineers can cast a solid, uncontaminated pillar of concrete, even when the hole is full of fluid. Once that concrete dries and hardens, crews chip away the very top layer, the part that touched the escaping mud, leaving behind perfectly clean concrete and steel. But before we build a bridge on top of it, how do we know this hidden pillar can actually hold the weight of a high-speed train? They prove it with a pile load test. The most common method uses a setup known as a Kentledge system. Engineers stack heavy deadlifts on a test pillar, adding weight until the load reaches 2.5 times its real-world pressure. The requirements are strict. To pass, the pillar cannot sink more than 12 millimeters, a fraction of an inch, under all that pressure. Once verified, a line of these pillars rises out of the earth, finally ready to hold up the elevated bridge. We usually only notice the massive concrete bridge and the high-speed trains above us, but all of that relies entirely on these carefully engineered routes anchored safely in the dark earth below.